Hello guys, my name is Naveed and welcome to my YouTube channel. Today we going to implement very interesting project like we will detect COVID from an X-ray image. Yes, it is very interesting. So let's start. I have made the previous some videos on the introduction of Google Colab, how you will can upload the data on Google Colab, how we can use GPU, TPU. So if you want to detail introduction, you can watch that video. So first of all, we will rename our notebook COVID detection. Great. After that, click on runtime, change runtime and select GPU because we will use GPU for our deep learning model training. Click on save, click connect, connecting, initializing. Great, it is connect now. So click on this folder icon. So first of all, we have upload the data in our Google Drive. So we need to first of all fetch our data from Google Drive to our Google Colab. For that, we need to connect our Google Drive with our Google Colab. So for that, you write the command from google.colab import drive. Then we need to mount the drive.mount, and what is address, content, and drive. So press shift enter is a shortcut key to run the cell. So if you click on this, it will run. After that, it will ask permission. Yes, I want to connect to my Google Drive. Then select your Google account. Click on allow. Click on this folder icon and you will see here drive will come. Oh, it's mounted. Refresh. Great. So it's expanded. My drive, YouTube sharing, projects, COVID X-ray, and data. So here we have the data. So we need to import this data into our Google Colab. So right click, copy path. Now we need to change the directory. So everyone that is from Linux, so we like we know use cd %cd to change the directory. So %cd, control V and shift enter. Okay. Now if you want to see the content inside this directory, write the command ls, shift enter. Great. We have COVID data and non-COVID. Now we will import all our dependencies. So right, import dependencies. Shift enter. Okay, great. Okay, now we need to import our all the libraries from 10. We import the TensorFlow, TensorFlow.Keras, Sklearn, some visualization libraries, matplotlib, SNSplot. So first of all, from TensorFlow.Keras.layers import input layer, lambda layer, dense layer, data layer, and from TensorFlow.Keras.models import model and load model. From TensorFlow.Keras.applications import. So we will use VGG16 for the training of our COVID X-ray images. So because VG16 is already trained on, you can say, the thousand of images, so we will use that learning to, you can say, solve our problem. This is the transfer learning. I will explain what is transfer learning. Don't worry about it. So VGG 16, yes, and from TensorFlow dot keras dot applications dot VGG16 import pre-process input from TensorFlow dot Keras dot preprocessing import image from TensorFlow dot Keras dot preprocessing dot image import. So we will also perform data augmentation. So for data augmentation, Keras have the function, you can say image data generator, that will automatically perform data augmentation for you. Don't worry. Image data generator. Okay. So for the evaluating our classifier, we will use some confusion matrix. We'll draw ROC curve. So from scikit-learn matrix import confusion matrix, then ROC curve. Then to visualize, for some visualization, we'll use seaborn and matplotlib. So import seaborn as SNS, then import your favorite library numpy as np, then import matplotlib dot pyplot as plt. Okay, when you load data, okay, you see, okay, this is my folder. After that, to get all the images inside a folder, you don't need to write a lot of lines, code lines. Don't worry, we have a function glob. So from glob import glob. Okay, to see the image in Google Colab, we have function cv2 underscore imshow. So from google dot colab dot fetches import cv2 underscore imshow. Now press shift enter. Let's see. Great. So now you can see Google Colab already have installed TensorFlow, Scikit-learn, seaborn, matplotlib, numpy, and many libraries already for you. So you don't need to worry like your environment configurations. Oh, if it's unrecognized command, this is the version. Don't worry. Just focus on your problem. So, but if you want to implement this project in your local system, yes, you can. I have made the videos where how you can install Python, how you can install VS Code, some VS Code extensions that help you in implementing data science project. So you can watch that videos. Okay, we have imported the libraries. Now we need to, you can say, define some parameters for our experiment. So first of all, text defining parameters, make it line, shift enter. Okay, now what would be our image size? Our image size would be 224 by 224. Why? Because VG16 accept the image of the shape 224 by 224. So image size is equal to 224 to 24. Then we need to define some, you can say, our training configurations. So how many epochs you want to run? Let's say we say 400. Now you are thinking, what is epoch? Epoch, you can say it indicates the number of passes of you want to pass your entire training data set from your model. So this is epoch. So I say I want to pass my data 400 times from my model. So it become more mature, more generalized. Then what would be the batch size? Batch size is equal to 32. Now, what is batch size? Batch size, you can say the number of training example we want to utilize in one iteration. Next, we need to define path. Let me know it. Okay, I think it's good. Okay, now I need to define the path. So, COVID underscore path is equal to COVID and non-COVID underscore path is equal to non-COVID. So now we use the glob function that will grab all the images from the specific path. So COVID underscore files is equal to glob COVID underscore path and concatenate with I want static all the files inside COVID path. Same for non-COVID files and non-COVID path. Just check the length of COVID files. Great, 435. Now we need to fetch the images and perform some pre-processing. Like you can say first read the image, then change its channel from BGR to RGB. Then we need to resize all our image to 224 by 224. Yes, because we are not sure like our image will always be in of this size. So for to make sure like our image should be of 224 by 224, we need to resize our image. For that purpose, we will use the OpenCV. OpenCV, you can see the library that help to perform image processing functions. So COVID underscore images and make empty list and COVID underscore labels make empty list. Same for non-COVID. Great. Now we need to, you can say, import the our OpenCV library, and its name is CV2. And you know what is the beautiful thing? Google Colab already have installed for you. Don't worry. So import CV2. Now for I in range, how much time? Just I say the length of files, number of files I have, length of COVID underscore files. Now first operation, read image. Second operation, change the channel from BGR to RGB. Third operation, resize the image. And at last, you can append all the images in this list. Start image is equal to cv2 dot imread, image read, and what is the path? COVID underscore files. First index is I, then next. Just like linked list. Don't worry, everyone from data structure know what is linked list. So then we need to change the channel from BGR to RGB. cv2 dot cvt color. First parameter is image, and second parameter is what you want to do. I want to convert from BGR to RGB. So cv2 dot color underscore BGR to RGB. Yes. Next one, image is equal to cv2 dot resize. First parameter image, and what is the size? 224 by 224. Yes. We have performed three operations. Now what? Just append in the list. So COVID underscore images dot append, because this is the list, this have append function, and image. And what is the label of this image? So COVID underscore labels dot append. I just want to say like COVID. Okay. Same thing we need to do, perform for all the non-COVID files. Just enter Control B. Here, non-COVID file, image read from non-COVID file. Then image, I want to convert this image. Okay. Then resize the image. Okay. Then append this in non-COVID images and non-COVID label. Run this cell. It will take some time. pixel take 5 minutes 52 seconds to complete. Yeah, this you can say around about 6 minutes. Okay. Now, if you want to see any your image training image, just use the function cv2 underscore I am sure and covid underscore images. I want to see image at my first index. Oh, this is right. That's great. Next, now we need to normalize our image. Like our pixel intensity is between 0 to 255. So we need to normalize our pixel intensity and bring between 0 to 1 by dividing by 255. So first, using numpy array, we convert into array and then divided by 255. So covid underscore images is equal to np dot array covid underscore images and divided by 255. Control C and same thing for non-COVID. We also need to normalize that image. So non-COVID, non-COVID. Shift enter. Great. Now we need to split our data set into training and testing. Actually, I am also formatting because I will upload this file on GitHub, so you can download and upload on your Google Colab and perform experiment and other tuning if you want to do. Okay. So split data set we use scikit-learn train test split. So from scikit-learn dot model selection import train test split, then from Sklearn dot Preprocessing import label binarizer, then from tensorflow dot Keras dot utils import to underscore categorical. Okay, so for split the dataset, then covid underscore x underscore train covid underscore x underscore test covid underscore y underscore train covid underscore y test. Yes. So is the function name train test split. Okay, first provide the first argument would be the COVID image, then COVID label, and then we pass like how much do we want to perform. For example, now we want to perform use 80% data for our training and 20% data for testing. So you can say for the test size argument would be 0.2, like 20%, 100 minus 20, 80%. So 80% data would be used for training. So COVID underscore images, then COVID underscore labels, and text underscore size is equal to 0.2. Okay, same for non-COVID. Non-COVID images and non-COVID labels. Shift enter. Okay, now we need to concatenate all non-COVID xray and COVID xray. So x underscore train is equal to np dot concatenate non-COVID underscore x underscore train and COVID underscore x underscore train and x is equal to 0. So for x test, y train, y test. X test test then y train and y test Y train, COVID Y train, non-COVID. Here we need to change test, test, shift enter. Oh, great. Now we need to, you can say the make our label to categorical, either 0 or 1. So to convert a multi-class label into binary label, we use the label binarizer. Then after that, we use the to categorical. This is utility function. So y underscore train is equal to label binarizer and dot fit underscore transform y underscore train. Y underscore train is equal to categorical and y underscore train. Same thing we need to perform for y underscore test. Test level by another fit. Now here test shift enter. Okay, great. Now we need you can see we need to build our model. So build model. Okay, so as I explain, like I will explain what is transfer learning. Actually, in transfer learning, we already have pre-trained model. Like it is this that model is trained on a lot of, you can say, lot of data, and it is very big neural network. So what we do, we use the learning of that model to solve our, you can say, problem, and we need to change little bit thing. First of all, for example, now we're using VG16. So VG16 last layer have the 1,000 categories, but now we have only 201, either COVID or not. So what we need to do, we need to do just cut the last layer, and we also need to, you can say, the pass the first layer and cut the last layer and add, you can say, our modified layer that have just 0 or 1, so either COVID or not. And after that, this is the one thing. A second thing, we need to freeze the learning. We don't want to you can say the lose that learning. So freeze the layers that they should not be you can say trained on our data. So let's start. VGG model is equal to VGG16, then weights is equal to ImageNet, make it pause, remove, and input tensor is equal to, what is input shape? Input shape is 224 by 224, and our image is RGB, red, green, blue, 3 channel. So 3. If it is in grayscale, then it would be 1 channel. So now it is in 3 channel. So shape is equal to 224, 224, 3. Great. It will download the weights from ImageNet, because ImageNet is a competition where they, you can say, this model is participate and this model win. So therefore we are using the VG16. Okay, it has downloaded. Great. Now we need to add the some layers at the last. So first we need to make that layer, and then we will add that layer at the end of VGG16. So first is outputs is equal to VGG model, okay, dot output. Then outputs is equal to, we need add a flatten layer. So flatten is equal to flatten outputs. Then we need to add a dropout. Dropout is used for regularization. We will explain every concept in our deep learning playlist, so don't worry. So actually you can say dropout is like with 50% we use dropout. It means 50% neurons will be, you can say, shut down during the, you can say, the training. So dropout is used for regularization. So we have different method, you can say, to avoid our fitting. We will discuss every concept in detail. Simply, you can say dropout is used for regularization to make your model more generalized to prevent from overfitting. So outputs is equal to dropout 0.5 and outputs is equal to, and at the last we need to add a dense layer, and it will have only two nodes, 0 or 1. So dense 2 node. So activation function would be softmax softmax and outputs. Yeah. Dropout is not defined. What is problem? Import dropout. Oh, sorry. I need to import here dropout. Yes. Shift enter and rerun this cell. Oh, great. Now we will create the model. So model is equal to model inputs equal to VGG model dot input, and outputs is equal to outputs. Shift enter. Great. Now we need to freeze our layers. So we make actually every layer have a parameter trainable. So make that parameter to false. So run the loop for layer in VGG model dot layers and layer dot trainable, make it false. Yeah, great. Now we need to compile the model. So in your during compiling, we will tell which loss function you use, which optimizer, and which matrix you use. Everything. So model dot compile. First thing is loss function. Loss is equal to categorical cross entropy. Then optimizer, we will use item optimizer. And matrix is accuracy. Categorical cross entropy is loss function, optimizer is item, and matrix is accuracy. So run this cell. Great. Now we have our compiler model. So if you want to visualize your model, so Keras have beautiful function dot summary. So call this function model dot summary. Shift enter. Okay, 224 to 24 by 3, and at the last we have two layers. Total parameter is this trainable param. Okay, non trainable. Oh, great. Okay, now we'll perform some data augmentation. So what is data augmentation? Actually, data augmentation is a strategy that increase the diversity of data available for your training without collecting your data. For example, in data augmentation, we crop the image, we rotate the image. For example, this is my face. So this is my face. You can say this is the first image. Second image would be I rotate my face at the, you can say, at horizontal flip, vertical flip, flip at 45-degree. So just like we change our images, so we create the diversity in our training data set. We increase the, you can say, the number of training without collecting data set. So data augmentation is, you can say, is used to perform, or you can say to increase the performance of your model. So now you are thinking how I can rotate my image, how I can flip, horizontal flip, like this, like that. Don't worry, Keras have image data generator for you. So train underscore augmentation is equal to image data generator. Now you need to pass what operation you want to perform using during data augmentation. So rotation range is 20-degree. Okay, with shift range is 0.2. Height shift Range is 0.2. And horizontal flip, yes, I want to do. Shift enter. Okay, now we will start the training of our model. So we will call the function model.fit, and we perform data augmentation only on our X train and Y train, not on our testing data set. So history is equal to model.fit train underscore x dot flow and x underscore train, y underscore train, and batch size. Then validation data is equal to x underscore test, y underscore test. Then validation steps is equal to length of x underscore test divided by 32. Steps per epoch is equal to length of x underscore train divided by 32. And last thing is epoch. How much epoch? Actually, oh, we have defined the variable. It is very, yeah, epochs and batch size. So we don't need to write there 32 again. Yes, batch size. Okay, now run this cell. Shift enter. Great. Now model training have been started. So it will run on 500 epochs. So we need to wait. When it's completed, we will come back. Okay, guys, training is completed. Actually, it take 1 hour 20 minutes 51 seconds on GPU. So you can imagine, like, if this is the time is on GPU, so how much time it will take on CPU. So therefore, we are using Google Colab GPU. Anyway, so we have training of our model is completed. Okay, you can see accuracy is increasing 90%, 91%, increasing good 91%. And what about loss? Because loss should be decreased. Loss. Okay, so on first epoch, loss 0.4, 0.3. Okay, it's decreasing, and accuracy should increase 81, 84, 86. Great. Okay, now we will save our model. Because after saving this model in, we can say that with the H5 extension, we will use that same model for our model prediction. That same model you can use in your web application, in mobile application, like you can hit that API, and at that API will return you response. So to save the model, just model dot save, and what is name of model, VGG underscore, you can say just dot H5, shift enter. And now at the next we need to save the weights. Actually, actual learning is in the weight matrix. So model dot save underscore weights, and name of file vgg weights just dot hdf5, shift enter. Great, now our model is saved. So now you have saved the model, so you can give this file to any your friend that want to use your model and get the prediction either he have COVID or not. So for how we can load the model, so just model is equal to load underscore model, and this is the name of our model, VGG chest H5, control C, control V, shift enter. Okay, we have loaded the model. Actually, here you can see we have the variable during training history. Okay, in history we have the accuracy, loss, So we can also make the some graphs so we can realize how our accuracy improve and how our loss, because here are the numbers. So it is very difficult for us to realize either how your model accuracy improve or not improving, or either loss is decreasing or increasing. So it's better to realize. So let's realize. Mm, just write some text. Realization. Okay. Okay. Now we'll use plot. First, we need to define what with my figure size. So figure size is equal to 10 by 10. Okay. Next, plt dot plot history dot history, and first we will plot accuracy. Then plt dot, actually this plt from matplotlib dot pyplot plot history dot history and validation accuracy. Okay, next, now if you want to assign some title to your graph, so simply plt dot ti title model accuracy, then y label and x label. So y label is accuracy, x label is epoch. Then at the graph sum we have legend. So plt dot legend training testing plt dot save page. We also want to save our graph. So what is the name of my file? VGG test accuracy dot png, and to show the graph plt dot show, shift enter. Oh, great. So this is my testing accuracy, and this blue one is training accuracy. Now same thing, if you want to plot your, you can say the loss of your model, just copy this paste and paste here. Okay, after that simply we need to change here at the place of accuracy loss and validation loss, model loss, epoch training testing, and name of image is loss. Hit enter. Okay, so you can see at the training, blue one is training loss. So here is you can see the model loss was, you can say, the 0.4, then it start decreasing, and this orange one is our testing. So here you can see it was 0.3, then it start decreasing, then again and go at the top, then start decreasing. So don't worry, we will actually, the purpose of this video just to, you can say, the guide you how you can make the a simple project that detect the COVID from X-ray image. So I will share this notebook with you, so you can perform different tuning by changing the optimizer function, by using different model. So you can perform different tuning to improve the accuracy of model, to decrease the loss. So as we have saved our model. So now we will try to make some predictions, like how in the real life, because in the real life you have saved the model, then you give image to your model, and model predict either this image is the COVID person or not. So for making prediction, model dot predict x underscore test, and batch size is batch size. Oh, great. We'll also realize our prediction. So prediction is equal to y underscore prediction. Actually, this is the list. So we will try to realize only first 10 prediction. So 0 to 10. Okay. Now for index, and actually prediction have the probability, how much probability like this person has COVID. So here we need to define some threshold. If the probability is greater than 50%, okay, this person has COVID. If probability is less than 50%, so we need to define this threshold. So probability in enumerate and prediction. Okay, if probability is of one at one first index, actually this is second index, if probability is greater than 0.5, like 50%, this is the threshold value. So I want to say like this person has COVID, like this is the probability. So plt dot title, so the title of our chart would be perform some string operation, floating night, and get probability 1 into 100 plus percentage COVID control C, else title. So this is the 1 minus probability 1 to 100, that is non-COVID. Okay, then plt dot im show the image x underscore test, this index and plt dot show. Oh, great. So here you can see like this image, he said 98% is the probability like this is the COVID patient. This at 100% probability like this is a COVID patient, this is a COVID x-ray image. So you have realized, like you can say you have realized the predictions of your model. You can say first 10 prediction. Actually now we need to convert to our, you can say, the prediction into binary class. So convert the probability vector into target vector, like for example, just realize like if you have vector like 0.5, 0.3, and just just for example, take the example and realize your model predict this. So we will take the maximum like this one. This is the maximum 0.5 probability. So you can say this is the class A, class B, and class C. So we will say this output is class A. So after you're getting the maximum, we'll say 1, 0, and 0. So same thing now we are going to perform on our prediction. So y underscore predict underscore bin is equal to, actually for getting the maximum we can use a numpy argmax function. Y underscore predict and x is equal to 1, y underscore test underscore bin is equal to np dot argument max y underscore test and x is equal to 1. Oh, great. So now we'll draw our ROC curve. Actually, ROC curve, you can say, is the receiver operating characteristic metric to evaluate our classification model. Actually, ROC curve typically feature like true positive rate on y-axis and false positive rate on x-axis. This means like top left corner of the plot is the, you can say, is the ideal place where true positive rate 1 and false positive rate is 0. Actually, I will draw the ROC curve, then you can clearly understand how we can understand ROC curve and what is the ROC curve of our classification model. So false positive rate, true positive rate, threshold is equal to ROC underscore curve y underscore test underscore bin and y underscore predict underscore bin. Okay, so actually now we get the false positive rate and true positive rate. So we just need to visualize on the y-axis and x-axis. So we will use the matplotlib. So plt dot plot false positive rate and true positive rate. Plt dot slim 0.0 1.0 plt dot ylim 0.0 1.0 plt dot rc params font dot size is equal to 12. What would be the title of our graph? So ROC curve for our model COVID, then X label and Y label. X label is false positive rate and Y label is true positive rate, and at the last plt dot grade. So it show the boxes PIU true and run this cell on. Now run this cell. Okay, now you can what I was saying, like this is the, you can say, the ideal point where true positive rate is 1 and uh, false positive rate is 0. So this is, you can say, is the very ideal point, but you can say the this is not possible in real life projects. So the steepness of ROC curve is very important. Next, we make the confusion matrix and classification metric of our classification model. So for confusion metric, simply confusion matrix y underscore test underscore win y underscore predict underscore win. Okay, so is 83, 4, 6, and 9, 5. Actually, this is the true positive, false positive, actual, and predicted. But I know this is not looking very good, so we can make it very interactive. So we're just using the matplotlib and seaborn library. First define the function, simply plot confusion matrix. So classes is COVID, non-COVID, tick marks is equal to 0.5 and 1.5. Classification matrix, simply copy this. Now you will see how we will make it very interactive. Enter. Then using this the seaborn SNS, we will plot the heat map. Heat map, this is classification matrix. C map is equal to plasma, and yes, I want to annotate true. Then x6 y6 title, that's basic. So x takes take underscore marks classes LTY take underscore marks classes. So title is peer matrix, PLT X label is predicted label, and PLT Y label true label. but not least plt.show. So simple plot European matrix. Okay, great. So we have, you can say, draw the confusion matrix, very beautiful. So if you want to understand this confusion matrix, so we can say model predict 86 people have COVID that actually have COVID. Like model predict 86 people have COVID that actually have COVID. So this is the true positive. So and one people to one person model predict like this person has COVID, but actually this person does not have COVID. So this is what is, this is the false positive. Then if you come to this, so model predict one people doesn't have COVID, but actually he has the COVID. That was a COVID patient. So this is a very serious problem. So this is the false negative. So and 95. Actually, this the value is 95. So 95, but 95 people, the model says these 95 people doesn't have COVID, and actually they don't have COVID. So this is a true negative. So at the last, we can also define, you can say the classification report. If this is, you can say the text report of your classification matrix. So simply from sklearn dot matrix import classification report and print classification report y underscore test underscore bin and y underscore predict underscore bin. Okay, so now this is our, you can say, our classification report. Actually, this is the precision, recall, F1 score, sport, and this is the accuracy. So this is the macro average and weighted average. Macro average, you can say this is the averaging the unweighted mean per label, and weighted average is the averaging the sport weighted mean percentage. So that's it for today. If you like my video, please subscribe the channel and hit the bell icon.